Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 50s on the screen. Let's get started, please. Shouldn't take you guys long. Is everybody doing good? Nice weather going, yeah? Oh yeah. It's almost to the point where I'm going to start wearing a sweater, but not quite there yet. We're getting there little by little. I'm sorry? Oh, no, at all. Nope. Yep. Hey, what? What? Thought you were going to say, do we have a pop party on Friday? What? Let me get started with a warm-up. Ooh, that was good, right? That was a good segue. All right, check with the neighbors, see what they got for the warm-up, please. They should be just about done. All right, here we go. Number one. First, they asked us to graph f of x equals x cubed. Who remembers the 5 points for that one? Of course, Miguel's got this. Very good, Miguel. Jacob's got this. I see you, Jacob. Autumn, of course. But let me go over this one myself. To graph f of x equals x cubed, we need -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Guys remember that, yeah? The graph looks something like this, like a wiggle. But then they're asking us to transform it according to this, so in order to transform it, I need to put a little cube here on the parentheses, because it's a cubic. Which direction are we moving it to? 3 steps up and 5 to the right. But before we do so, we need to do something with those points according to this. So instead of -2, 8, it's going to be -2 what? Yes? Okay, are you guys copying my stuff? -2, 8 was the original, but what is 8 times 2? 16, so it's -2, 16, way down here. It doubles. Bah! -2, -16. So that means that -1, -1 becomes -1, -2. 0, 0, 1, 2, and 2, 16, way up there. So since it's stretched, then now we move those 5 red points, 5 to the right, 3 up. So our new function is going to be stretched and somewhere up there. All right, let's go to number 2. What'd you get for number 2? Tell your neighbor. And then I'm going to have Carlos and German enlighten us with number 2. Tell your neighbor what you got. All right, Carlos, 2A, what'd you get? 1 over 8 to the power 1. Hands if you got that. That is correct. What'd you get for 1B, German? 1, that is correct. How about 1C, Carlos? Blank. And then we distribute the -2, so it's 1 to the -2, 7 to the -2. But we can't have negative exponents, so we send that one down, that one up, so we end up with 7 squared over 1 squared, which is 49 over 1, or just 49. Ah. Look at 3C. Tell your neighbor what you rewrote that according to 3C, and then we're going to have Carlos pat someone. Tell your neighbor what you got for that one, 3C. Scarlett, guide us through this one. So what do I write? 4 to the x. Oh, hold on. 4 to the x times 4 times -2 to the -2. Can we have negative exponents, people? No, so that goes to the denominator. We keep 4 to the x on top, and we change the negative exponent to a positive. So it's 4 to the x over 4 squared, which is 16. Last but not least, tell your neighbor what your long division came up with. Show them what you got, long division. They should be experts by now at that, because we're going to be using that today, by the way. Yay. Hey. All right. Scarlett, pass someone. Yes. No, good. Answer, go.
On the 2 over x minus 2, 6.
2 over x minus 2 plus 6. Hands, have you got something like that? Okay, however, is this the number that I always have on the numerator? No, so we need to send that to the front. And what do I write on the numerator, everyone? 1, that is correct. Everybody seeing what we're doing, yeah? Yes, thank you. All right. All right, copy the agenda, please. Oh, before that, send me your warm-up. I want to see what you did. All right, thank you, guys. So you copy the agenda, warm-up number 50, done. We're in the middle of rational functions. Today we're moving on to more complex ones and the simple ones we've been working with. But mostly you already have all the processes. I've been giving you little bits and pieces here and there. Tonight's home play is numbers 13 to 17 from pages 396, 397. You're going to have access to those pages with the code you just wrote down earlier. Okay? Or did I give you code already? No, I have it. I'll give you the code right now, as soon as you copy the agenda. Man, in the morning it was slippery out there. When I got here. Really? Be careful. I was about to say, because now imagine me, like I have my walking stick that I use. I have to like really like focus. I was using the force. So I was focusing every little step I took. Wow, be nice. Huh? What's that? Yeah. All right. Copy the code. EDSZR. Write that down. EDSZR. When you log into Nearpod with that code, the very first thing that's going to pop up is those 2 pages for the home plate. Okay. All right. EDSZR. So, tonight's home plate, once again, 13 through 17 only. All right, here we go. I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. By now, when I say rational functions, 2 things should come up in your noodle. Tell your neighbor what they are. What are the 2 things you think about when you hear rational functions? What do you hear? What comes up in your noodle? All right, let's go with Leo. What are the 2 things that come up in your noodle, Leo? What? Rational functions? Fractions? And equal signs. Very good. Fractions and equal signs. That is correct. Bless you. So we've been graphing and transforming functions using those steps. Today, we're adding a couple more steps. Look up. Look at that. Look at that. Tell your neighbor what's the only thing we're going to add to the steps first. What? An extra step. Wow. Very good. Yes, an extra step, which is long division. However, we're also going to get into writing from a graph the equation, which is all these steps. I'm not going to have you write them down. You have the code where you can go and access the presentation. However, let's get straight to the work, yeah? So look up. We've covered our general rule. We know what K, H, and A do. We can apply it to this, and it does the same thing. But we also know that after that, we introduce asymptotes. We're working vertical and horizontal. Is that correct? We haven't gone to the diagonal type. And we know that from our general rule, K is our horizontal. Horizontal means side to side, like that. And H is our vertical, which is up and down, like that. Is that correct? All right. From there, we did a lot of practice with these simple ones. But today, we're moving on to these. Copy this one on the top left of your graph, please. Example number 1 says, rewrite the function and graph. Rewrite the function and graph. Rewrite the function and graph. G of x equals 3x minus 4 over x minus 1. G of x equals 3x minus 4 over x minus 1. All right, so once again, for this one, we started with long division. So we did 3 times x, 3 times negative 1. That gives us this. Remainder, we had 3 and negative 1 on the numerator over x minus 1, but we can't have that on the numerator, so we moved the negative to the front, the 3 to the back. We ended up with this. We wrote g of x equals that. So in order to graph this, we start with our parent function. We got our zeros, got our asymptotes there, our points there, and then from there we moved it 1 to the right, 3 up, 1 to the right, 3 up, and then we got our new asymptotes. Technically we had these 2 points here, but the negative made us flip them upward and downward. Okay, from 1 to 5, how comfortable are you with that so far? 3, 4 is 5, 3 is 2.5. Some of you have weird fingers. All right, let's move on. Copy this one. Example 1Q, 1Q. G of x equals 4x minus 7 over negative 2x plus 4. G of x equals 4x minus 7 over negative 2x plus 4. All right, so let's do this one together. Here it goes. What do we do, everyone? Step 1 is to do what? Tell your neighbor again. Long division. 4x plus, minus 7. My bad. Hold on. 4x minus 7 divided by negative 2x plus 4. So, what number times negative 2 gives me positive 4? Negative 2. So negative 2 times negative 2x is positive 4x. Negative 2 times 4, that's negative 8. We're going to subtract, and I remind you to circle that to distribute that here and here. So, this cancels. That leaves us with 8 minus 7, that is 1 as a remainder. So what is the answer to this division? It's negative 2. But since we have a remainder, we put plus fraction bar. What goes on top? The remainder, which is 1, over negative 2x plus 4. Can we leave it like that? No. So therefore, we send this one to the end. So we end up with 1 over negative 2x plus 4 minus 2, and all that equal to g of x. All right, let's graph that. We start with our parent function, f of x equals 1 over x. That means we need our HA, f of x equal to 0. our VA, x equal to 0. Technically, we have a point 1 up, 1 to the right, and this one. All right. So, according to this, we're moving it in which direction, people? 2 down, is that correct? However, this one's kind of funky. How do we know what x is? Or where to move it to? What do? Set it equal to what? 0 and solve. That is correct. Minus 4 minus 4, negative 2x equals to negative 4. Divide by negative 2. So x equals 2. So we're going to move it to the right 2 and 2 down. To the right 2 and 2 down. To the right 2, 1, 2, and 2 down. All right. So our new HA, VA, is everybody there so far? All right, so technically we have 1 point here and 1 point there. However, let me show you one last thing that we need to do with our function. I want you to write it somewhere else because we're going to do some work with it. So let's fix the denominator. Look at the denominator. Let me zoom in. Question. What would be GCF if I was to ask you for GCF on the denominator? Negative 2, is that correct? So that leaves us with x minus 2. We have 1 on the numerator and then negative 2 at the end. Okay. Is everybody following so far? Okay. So now, check this out. This I can split up into 2 fractions. The first fraction is 1 over negative 2. The second fraction is 1 over x minus 2. You guys agree with that so far? Yes? However, we can't have a negative on the bottom or at the top. Where we're going to send that negative 2? To the front, yes? So it's negative 1/2 times, or parentheses, 1 over x minus 2, and at the end, minus 2. That is g of x. So now by looking at that, no? Okay, let me go back. We're taking the denominator only. So negative 2 is here. So negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Are we there so far? All right. This fraction, we can split it up into 2 fractions, because what is 1 times 1? 1. And what is this times that? Well, that. Is everybody following so far? All right. However, we can't have a negative on the denominator, so I just move it to the front. So my first fraction is negative 1/2. Instead of writing the multiplication sign like that, I open a parentheses for multiplication, 1 over x minus 2, and I just bring down the negative 2 that was our k at the end, yes? So with that said, where do we move this to? Let's see if we got the same thing that we thought about earlier. It's 2 steps down, is that correct? And 2 to the what? To the right, okay. So did we do that? Let me zoom out. 2 to the right and 2 down, yes. However, look up now. What does that do to the two technical points that we have? Flip, so let's say we bring it here and here. However, what does this half do? Instead of going a full step, I do what? Half step. Half step. And there you go. So I think we're good with the entire process, but where we're going to have to like really look at is this part, rewriting it at the end. All right? So let me send you the screen so you can send me your notes really quick. Give me a second. All right, let's do another one. I'm going to give you a head start on this one. Example 1, super Q. 3x plus 8 over x plus 2 equal to g of x. G of x equals 3x plus 8 over x plus 2. Now, you should be able to do this one completely, so I'll give you a head start. Copy and go. All right, check with the neighbor, please. See where they're at. See if they have the division correctly. All right. We good? All right, get us started, please. What did you do first, Geo? Long division. So 3x plus 8 divided by x plus 2. So tell me what you write. Oh, it's frozen? Oh, my bad. Let it go. Let it go. All right. Number 3. So 3 times x is 3x. 3 times 2, that's 6. We subtract. Distribute here and here. So we end up with what? 2 as remainder. So our answer to that division is 3 plus fraction 2 over x plus 2. Hands up, you got up to there by yourself. All right. Let's see, pass it to Julian. Oh, Julian, what do we do next? Bring the 3 to the other side, and what else? Bring 2 to the front. So tell me what to write. G of x equals like that. Hands if you got that. That is correct. So where are we going to move that to? Pass someone? Allison, where are we going to move that to? 2 to the left, 3 up. All right. So let's graph f of x equals 1 over x. So we have our HA at f of x equals 0 and our VA at x equals 0. My original point is 1 to the right, 1 up, 1 to the left, 1 down. And Allison said we're going to move it 2 to the left and 3 up. So 2 to the left, 3 up. All right, and technically we have a point here and here. However, pass someone, Allison. Hyman, what are my 2 final points? Where do they go? Negative 3, 1. Negative 1, 5. Hands if you got that. That is correct. Now, why, Mr. Q? Because this 2 tells us instead of 1 step from the asymptote, we take 2 steps. This one again, instead of 1 step, we do 2 steps. Send that in, please. From 1 to 5, how comfortable are you with this? 5, 4, 3 and a half, 5, 5. Yes, we got this. We just need practice. All right? So, look up. So if I was to give you this one, you should be able to do that one by yourself. Is that correct? Yeah, so we're not going to do that because I just want to get to the next problem. So let's go to the last graph that you should have. As a matter of fact, go to the biggest graph that you have. The biggest graph. Copy this, please. Copy the actual graph, please. I'll give you some time. Copy that. Go. All right, does everybody have the graph already? All right, here we go. First things first, on the left side, I want you to write example 2, and I want you to write this form really quick. G of x equals a parentheses 1 over x minus h, close parentheses, plus k. So the instructions were write the equation of the function given the graph. So now they give us the graph, and they want us to write the function that transformed our original graph to that. So, let me pause the music, look up. What values are we missing from our equation, people? We're missing what? K, H, and A. So check this out. We know that K is our what? Our HA. Is that correct? So, by looking at the graph, tell your neighbor what our HA is. What is our HA? Everyone? Everyone? See what I did there? Yeah, 1. Here it is, right there. All right, next, we know how to find our VA, or X equals. So tell your neighbor what our VA is. What is our VA, everyone? -2. So that's our VA, which is here, -1, -2. There it is. All right. So the only thing we don't have so far is A. However, we do have an X. Look up, please, or you're going to miss it. We do have an X, and we do have a G of X. You're like, where, Mr. Q? Well, look up. Don't they give us a point with values? Which one do you want to use, the top one or the bottom one? Does it matter? No. So which one do we use, guys? The top or the bottom? Top or the bottom? Top. So label this one X and this one G of X. So now that we have all our values, check this out. We're going to substitute values in here. So here, instead of writing G of X, what do I write? What do I write? 5. Equals. Focus, please. Bah. Let's see. What was our X? Our X was -3. What other values do we have? Our K. What was our K? +1. And what was our H, or our VA? -2. So what's the only thing we couldn't find, everyone? Label that A right there. All right, let's simplify this fraction right here. So we got 5 equals A times 1 over negative times a negative here is a positive. -3 times 2, that's -1 plus 1. So far, so good? So what is -1 over 1? -1, right? So that is A times -1 plus 1 equals 5. Next, what is a times negative 1? Negative 1a plus 1 equals 5. Let's solve for a. What do I do to solve for a? Minus 1, Mr. Q. All right, minus 1. So we got 4 equals negative a. And lastly, divide by negative 1, divide by negative 1. Therefore, negative 4 equals a. Yeah. Say it again. Yes, we can get that by counting, and we'll check that right now. However, I want us to do algebraically because sometimes we're going to end up with fractions, and you're not going to see the process up to right there. All right, look up, please. So now that we have all our components, we rewrite this. G of x equals, instead of a, what am I going to write? Negative 4, parentheses, 1 over x minus, what was that number? Negative 2. And then plus 1. Is that correct? However, this negative times a negative becomes a positive. And that's how we write our function. Now, look up, guys. This is what Julian was saying. Mr. Q, can't we just find a by what you showed us? I'm all like, what? What do you mean? Well, here's our asymptote. Look up. Look up, please. Here's our new asymptotes. Technically, we have a point here and here. Is that correct? So, but now it's on the opposite side. So what does that mean? That the whole function is what? Flip. It's a negative. Okay, so far we got that. So now we move it here. But it's not there. It's up here. What do we do? Oh, my, oh, my. Count the steps, right? 1, 2, 3. How many steps? And that gives us negative 4. That is correct. En fuego. We're going to stop right there. Tonight you're going to have one of these to do. Let's see how you do with those. Those of you following on YouTube, make sure you put some work in. You have the code to log in. See you guys next time. Peace.